All right, here we go. Jamia collected data comparing the weight and cost of pieces of sterling silver jewelry. Her data is listed as weight in ounces, like our input value, cost in ounces via output values, or independent and dependent variables. So 5 ounces is $44, 8.5 ounces is $78.50, 12 ounces is $112, 10 ounces is $93, 7 ounces is $63.50, 9 ounces is $83.20. First of all, they want us to plot the data on a set of axes. So we have to take the time here real quick to plot these on a graph. You'll see I've already set up a graph for myself. My independent variable representing weight, or the number of ounces, and my dependent variable, or my y values here, the cost in dollars. So let's go ahead and start plotting these on here. Let's do the first one, 5 and 44. So we're at 5 ounces and we've got about $44 there. Then we've got 8.5 ounces. So it's going to be halfway between 8 and 9, and we're going to have $78.50. Just a little short of 80. Next we have 12 ounces and $112. So 12 ounces, we're going up just a little above 110. So 10 and 93. So 10 ounces, $93. 7 ounces and $63.50. And then we have 9 ounces is $83.20. So we've plotted all the points that we have here, all this information. Letter A asks us to, asks us to plot that data. Then letter B asks us to use a ruler to draw a line that best approximates the data. Well, I'm going to go ahead and use a line tool here. And I want to create this trend line. So I want it to hit as many points as possible, and I want to kind of try to spread them so there's as many above it as below it. Since these ones are so closely um, in line, or they're almost linear here, it should be pretty easy for us to create that trend line there. That looks about good. So this is that line that we say our data is following. It's our trend line. So we need to determine the equation of the line of best fit, which that is what this is, another word for trend line or line of best fit there. So to come up with our equation, that equation is going to be in slope-intercept form. This is letter C. So it needs to be in slope-intercept form there because it's a line. So we need to figure out our slope and our y-intercept here. So as you look at it there, you could see some places there may be points that are easier to work with or closer to like whole number values. Just need to pick 2 to come up with the slope. So I'm going to pick for myself here, let's look at, I don't know, doesn't matter. Let's do 544 and let's do something like 12112. Those ones seem like good numbers to work with. So $5 and $44, and we had 12 ounces was $112. So let's just get our slope, then figure out what our y-intercept is going to be, and then rewrite it there like they want us to. So here we go. Slope is going to equal 112 minus 44. So this y minus this y, and then that means we do 12 minus 5 in the bottom. Well, 112 minus 44 should end up giving us like 68. So we're going to have 68 in our numerator, and then 12 minus 5 should give us 7. So this ends up being our slope for our line. I know it's not the prettiest thing in the world, but it's pretty close to the value of 10. And let's see here, we're going to need to come up with the y-intercept. So let's do that. If we know that, in fact, you know what, let's take this. Let's just go ahead and round this up. Let's say that was going to be 70 over 7. That was pretty close to where this line is. So let's go ahead and make that slope 10. I think that's going to help us out a little bit here and come up with the rest of it. So we just took two random points. We came up with a slope. That slope was going to be 10 now. Can you always do that? Yeah, I could do that. I could pick whatever points I wanted off there. I just happened to choose 2 points that were given to us up here. But I'm just trying to come up with the slope of that line. So that line looks like it is going up about, just about 10 for every ounce that we're adding. So we're adding $10 for every ounce. So let's choose another point on the line there. Let's just use one of these ones, 44 and 5. So I know that x would be 5, y would be 44, m would be 10, and that will allow us to solve for b. So 44 equals 10 times 5 plus b. So we get 50 plus b equals 44. Let's subtract our 50 from each side. We get -6 equals b. That's our y-intercept. So if our slope is going to be 10, our y-intercept is going to be -6. We can come up with the equation would be y is equal to 10x minus 6. Lastly, use your equation to predict the cost of a 50-ounce silver bracelet. Well, 50 ounces, that's going to make our input 50. So let's see what happens. Let's do this one right down here. We got a little bit of room left. Let's do, this is letter D. We want to know the cost of a 50-ounce silver bracelet. So we're going to say y is going to equal 10 times x. And remember, x is the weight in ounces. So we're talking about a 50-ounce silver bracelet. So 10 times 50 minus 6. Well, 10 times 50 is going to be 500. Minus 6 should give us $494. So use your equation to predict the cost of a 50-ounce silver bracelet. The cost of a 50-ounce silver bracelet should be approximately $494. That's using the equation that we came up with. Yours might be a little different. You may come up with a slightly different answer there. It is possible. So this is problem 5-44. Hopefully this helped you out. Just remember, plotting your points, drawing your trend line, or your line of best fit. Then you need to come up with the equation for that so that you can make predictions by plugging in other values for your inputs and outputs there. 5-14, hope this helped. Get help from your teacher if you have questions.